We will now discuss the solution of a problem from the section three-dimensional geometry, and the problem is on the line of intersection of two planes. This question has appeared in JEE Main exam held on 22nd July 2021 in the afternoon shift. The problem is, let L be the line of intersection of planes. The planes are given by R, vector R dot, the vector I minus j plus 2k is equal to 2, and R dot 2i plus j minus k is equal to 2. If P with coordinates alpha, comma beta, comma gamma is the foot of the perpendicular on L from the point 1 to 0, then the value of 35 times alpha plus beta plus gamma is equal to. The four options are given to us. Let us now discuss the solution of the problem. We are given L, the line of intersection of the two planes, and that is L is the line of intersection of the planes. The first plane is R. R means xi. For R we write xi plus yj plus zk dot this vector I minus j plus 2k. So if you take the dot product, you will get x minus y plus 2z is equal to 2. That is the first plane. P1 is x minus y plus 2z is equal to 2. The second plane, similarly, P2 is given by 2x plus y minus z is equal to 2. Let's look at it. This is the first plane. This is the second plane. This is the line of intersection L. Now, to write the equation of the line, we need the coordinates of a point Q on L and the direction ratios of L. So Q on L and the direction ratio of L, if you know, we can write the equation of the line of intersection capital L. Now, to find the coordinates of a point on L, put z is equal to 0 in the above equations. We get these two equations, x minus y is equal to 2 and 2x plus y is equal to 2. On solving, we get x is equal to 4 by 3 and y is equal to minus 2 by 3. Thus, we have the coordinates of the point Q is 4 by 3 comma minus 2 by 3 comma 0, and it is a point on L. Let's look at that. Yes. We continue in the next slide. And we recall a result. If R dot N1 is equal to D1 and R dot N2 is equal to D2 are two given planes, then their line of intersection capital L is perpendicular to both N1 and N2. That is, L is parallel to the vector N1 cross N2. And in our case, we have R dot I minus j plus 2k is equal to 2. N1 is I minus j plus 2k. And R dot N2, that is R dot 2i plus j minus k is equal to 2. N2 is 2i plus j minus k. Thus we have N1 is equal to I minus j plus 2k, N2 is 2i plus j minus k. Then N1 cross N2 is the determinant whose first row is I, j, k, whose second row are the components of N1 and the third row are the components of N2. Now expanding the determinant by the first row and simplifying, we get the vector I plus 5j plus 3k, that is the vector n1 cross n2. Now L is parallel to n1 cross n2, that is L is parallel to minus I plus 5j plus 3k. From this we can write the direction ratios of the L. The direction ratios of L are minus 1, 5 and 3, and it passes through the point Q with coordinates 4 by 3, comma, minus 2 by 3, comma, 0. So the direction ratios are known, the points, a point on L is known, therefore we can write the equation of the line of intersection L. So the equation of the line of intersection L is x minus 4 by 3 by the direction ratio minus 1 is equal to y minus 2 by 3, that is y plus 2 by 3 by the direction ratio 5 is equal to z minus 0 by 3. So thus we have obtained the equation of L. We continue, and so far this is the story. So we have that the equation of the line of intersection we have written. Now proceed further. Given P alpha beta gamma is the foot of the perpendicular on L. So P is the foot of the perpendicular from the point R1 to 0. From the point R1 to 0, we have drawn a perpendicular onto L which meets L at P, whose coordinates are alpha, beta, gamma. So because alpha, beta, gamma lies on L, it satisfies the equation of L. So wherever there is x, y, z, substitute alpha, beta, gamma, we will get alpha minus 4 by 3 by minus 1 is equal to beta plus 2 by 3 by 5 is equal to gamma minus 0 by 3 is equal to lambda. Now we want alpha. Alpha minus 4 by 3 is equal to minus lambda. So alpha will be equal to minus lambda plus 4 by 3. Similarly, beta will be 5 lambda minus 2 by 3. Gamma will be 3 gamma. So now let's write down the vector PR bar. PR bar. We know P is alpha, beta, gamma, R is 1 to 0. Therefore, the vector PR bar is written as alpha minus 1i plus beta minus 2j plus gamma minus 0k. So, PR bar will be equal to alpha minus 1ji plus beta minus 2j plus gamma minus 0k. So, on simplification, we will get the vector PR bar as minus lambda plus 1 by 3 I plus 5 lambda minus 8 by 3 j plus 3 lambda k. So, that is the situation so far. So, PR bar vector we have written. Now PR bar is perpendicular to L. PR bar is perpendicular to L and L is parallel to this vector minus I plus 5j plus 3k. Therefore, PR bar is perpendicular to minus I plus 5j plus 3k. So this vector PR bar is perpendicular to minus I plus 5j plus 3k. Then we get, take the dot product, minus lambda plus 1 by 3 into minus 1 plus 5 lambda minus 8 by 3 into 5 plus 3 lambda into 3 is equal to 0. The product of their direction ratios and then sum it up, then it will be equal to 0. So simplifying, we'll get 35 lambda is equal to 41 by 3 and lambda is equal to 41 by 105. And we have alpha, beta, gamma, and we want alpha plus beta plus gamma. So alpha plus beta plus gamma is, you add these things, you will get 7 lambda plus 2 by 3. Now substitute for lambda. So is equal to 7 times lambda is 41 by 105 plus 2 by 3, and that will be equal to 41 by 15 plus 2 by 3. When simplified, you will get 17 by 5. Now what we want is 35 times alpha plus beta plus gamma, and that is equal to 35 times alpha plus beta plus gamma is 17 by 5, and simplifying we will get 119. So let's look at our options. So our answer, 35 times alpha plus beta plus gamma is equal to 119, appears against the option 4. Therefore, our answer is option 4. Thus, we have come to the end of the discussion of the solution of the problem from the section 3-dimensional geometry, and the problem is on the line of intersection of two planes. And work out similar problems from 3-dimensional geometry, and I wish you all the best. Thank you.